What is going on, ladies and gentlemen? It is almost that time. We're going to get it one more minute for all the YouTube bells, notifications, and everything else to pop off. We are got a amazing show coming up with the Smoking Ape. He's going to show me a lot and teach me a lot about balance. So, what is up, everyone in the chat? uh, do you plan to review other Miller products? That's funny. That's funny. All right, I think that's good enough. Let's go ahead and kick this off by turning down my volume because we all know what's about to happen. Here it is. What is going on, y'all? I'm Frank, KG5HJ, and you know what time it is? It's play that awesome intro time after I find it. Where is it? Long intro. Here it is. There we go. Quick shout out to all my Patreons who makes the show possible. You can support me by joining Patreon in the link below. And on to Tank Radio. Boom. Look at that. Almost professional again. Almost. We'll turn it down a little bit. There we go. I like those levels. Howdy y'all. Howdy y'all. It's been an amazing 2 weeks since we hung out with y'all. Actually, maybe it was a little longer than that. I took a Sunday off between Dayton and everything else happening, man. It's been busy. Auto 45, how's it going, man? Nice to see you in there. But let's just do the quick normal rundown. Thank you to all my supporters. Y'all are amazing. You saw your name. Roger, what's up, man? I see the double tank. Y'all are amazing. Thank you to all my YouTuber members and also Patreon's supporters. I thank y'all each so much. At the top of the chat right now, and also in the description if you're listening later, there is the link to my whiskey tumblers. These whiskey tumblers are a limited time item. I think this is the last week for them. So if you haven't got your whiskey tumbler, here it is. Boom! And a peek at the April fast. These two whiskey tumblers are on pre-order right now for $40. Technically a sale down from $45, and hey, it's not at 45. These are pre-order only items. Once they're out, there's going to be no more. And this is the last week to get them. So go ahead and head over to Grapevine Amateur Radio or shop.hamradio2.com. Jesus, that is a mouthful to say. Jason, URL shortener. And my coins are still over there at the Grapevine Amateur Radio. You could pick up a cool Tank Radio coin. I've still got those for sale. And also in the links, you'll find a Gigapart link for 5% off on Gigaparts. And my audio podcast, this is being recorded from my audio podcast. It's going to be released in the audio format. You go ahead and get that anywhere you have a audio podcast catcher. There is two episodes a month on the audio podcast that aren't released on YouTube. So head over there. They're great episodes. There's mostly the one episode is Tank Cam Boys, where we talk about kind of everything going on with the Texas YouTuber group. Jason's a regular contributor. Mike KMRD. Shane drops in from time to time. Scott, my man Scott, who is busy, I think, right now. That's fine. And we have a couple others join us occasionally, and we just talk about what's going on our channels, what's coming up, and all the cool and fun stuff. And the other one, you just got to head over there and find out. But go and just search for Tank Radio. It is amazing. I think I hit all my points looking at the rundown list. Yes. Look, I am such a professional. I still don't know how Jason does a run-up for 7 minutes. I can't talk that slow. So let's go ahead and bring in my man, the smoking ape, and mute. There we go. What is up, man? How you doing?
Good, man. It was cutting out on me really bad. Is it am I okay? Am I
You're
live? What's
showing
going on
red.
here?
You're live right now.
And I'm
You're
showing red.
yeah, red in Zoom. Your connection little bars are red. Oh, now you're up to yellow.
All right, well, how about that? Yeah, I
Yellow,
don't know,
yellow.
man. It seemed like it was lagging pretty bad there.
Mm-hmm. It looks fine to me right now. So let's just roll with it.
All right.
If you drop, and just call right back on in, man.
Now we can do that.
So I need to hang out with you more, man. Your
That might not be good
intelligence
for you.
needs to rub off on me. I have been learning a lot about. If y'all been watching the channel, antennas, building antennas. I built dipoles. I've built end-fed half-waves in kits. I did the math on how to calculate your end-head half-wave, and if I ever get around to release it, it's done and uploaded. There is me building the end-fed half-wave and proving out all the measurements I did and operating on it. Great linked end fed halfway. Shout outs to Mike KMRD, who I guess was the official first one to build a end fed halfway, where he's trying to take credit for it. But I was like, I think the idea of a end fed half wave,
He said he was the first one to do it. Is that right?
first one to film it on YouTube. So I'm going to give him that part. But
When did
the
he do that?
idea of an end-fed linked end-fed half-wave antenna has been around for a while.
Oh, you
Oh,
said a linked and
yeah,
fed half wave
and
antenna.
linked end-fed half-wave. Also, I forgot to mention I have a cool box we're gonna open up later on the stream from one of y'all sent me. I can't wait to open this. I know it's in here.
Yeah, we were originally going to sell the Apollo as a linked and fed half wave, but
Hmm.
I didn't want to do it. I thought that I didn't like that idea.
Well, it's up to y'all to do it. You got to figure out what bands are important. So you can't just sell a kit kind of like out of the box, because you also got to tune it for your area.
Yeah, well, the
So,
thing is it's a kit, it's a platform that we
hmm
sell that
hmm
allows people to make it their own. They can do whatever design changes they want to
hmm
it.
hmm
And I think what we do is we encourage people to make modifications to it as they learn and grow, and they can change out different components of it and stuff like that.
hmm
But I wasn't one of the things that we do is we support it, right? So we get lots of
Yep.
questions from people who are building it or have issues or challenges, or they just want to ask questions about it. And when you add the complexity of linking, I know it doesn't seem like it's a very complex thing, but what we didn't want to have to do is have somebody cut their wire incorrectly, and then they can't get it on 40, right?
Yeah. Yeah. Well, I cut. So I have a 200-foot wire I bought. And then when
Mm,
I was doing the linked sections, I was cutting each section out individually. The first section was for 17 numbers offhand. I think 30 feet ish. Don't quote me on that. Do your own math. I'm just throwing out a number. It sounds no 30 is not right. It's shorter than
no, it
that.
doesn't sound right.
Anyways, I cut the first section. I'm scrolling through my notes. I might have it here still. Nope, nope. Oh, I do, I do. For 17, that was 9 feet. 9 feet? Oh no, wait, that was after
I
all
was
that.
say,
25 feet for
okay.
17 meters.
I said nine. I'll have to take your word for
Well,
it.
9 was if you cut this was the whole link sections. If I cut a 10 meter link section, and then if I was going for 17, I need additional 9 from the initial 10 meters.
Gotcha,
And then
gotcha.
if you're going to do 20 on top of that, it was going to be additional 7 feet. I'm doing feet, not meters. For my measurements, bands I'm in meters, length of wire in feet. Then for 40 past that was additional 32 feet. Um, but yeah, so I did all these link sections. I talked about harmonics, and well 20 is not that long, so we don't really need a 10 meter um uh, e- element. So I just condensed that down to, well, if I want to play on 10, I'm just going to run 20, and if
Yeah,
I
you
run
just
them all, I'll
gotta,
just run 40.
or you get a harmonic from
and
20 on 10.
and I call it my lazy man antenna, because I only want to put up 20 because I'm only going to work 20, so I don't need to run out whole 40 meters and whole 65 feet of antenna cable to
Yeah,
get on
I
all the
mean, I think that with
harmonics.
with 20, you're good at around 33 feet or something like that.
Yeah, yeah.
So you're like around 62 with our wire. It has a different velocity factor because of the silicon jacket. So
Mm-hmm,
I'm sure you're aware the velocity factor is heavily influenced by the
mm-hmm.
insulation on your antenna wire. And so the car antennas actually they're cut a little bit shorter than typical. That so I think like our 40 is around 62 feet, and
Mm-hmm.
I think traditionally it's more like 64 to 66 feet,
Mm-hmm. And
something
I'm
along
dropping the
those
link
lines.
in the chat for the Coffee and Ham Radio's
Oh, thank
antennas.
you, thank
Um,
you.
I did pick up at Dayton the 9-to-1 version of the Coffee and Ham Radio antenna, and
Nice.
I need it. So that's a kit where I put it together, I think.
It is.
Yeah.
It is.
So I'm looking forward to doing a video on that. It's in the lineup of everything.
Well,
Um,
let us know when you get the video done, and we'll put
yeah,
it in the playlist that we have.
I need to get it in the hopper. There's my linked me building and testing the linked dipole antenna is next in the queue for the major releases. I just filmed something for Field Day, which is probably going to bump that because I want to get it out before Field Day. Is you know how it is. You know how it is. Hey, ham and crackers. Thanks for swinging by. But the 12 minutes into it, and we finally get to the topic of the day here. I want to know more about toroids. Toroids, what do they do? Kind of what's some of the science behind it, and how they do the things that they do. And that's kind of go back to what do they do? Why do I need a toroid?
Well, a lot of people tell you don't need one, right? And so YouTube's littered with people who are making dipole antennas, and they don't put a one-to-one on those antennas, and they're like, it works just fine, boy, it's just fine. And so part of the challenge that we have is that you get so there's tow roads are used for lots of stuff. Let me start there. What you do with them is that you create impedance and you create it through inductance, right? And so if you think back to my screen just changed, I'm assuming you're doing
Oh
something.
yeah. So my feedback is what I'm showing y'all.
Okay, so if you think back to you when you took the general test, there are a lot of questions on there around tank circuits,
Mm-hmm.
right? Which is an inductor and capacitors in different configurations that become resonant circuits, and then you can use those resonant circuits to manipulate RF energy. And so we use toroids in all kinds of things. They're inside your radio, they're inside your tuners, they're parts of your antenna systems because you may want to create add some inductance to create a certain type of impedance so that you can manipulate RF. So I guess initially we'll talk a little bit about dipole antennas because they're simple. Everybody knows about them. Everybody uses them. And when you have your transmission line that goes up and it connects to your elements, right? You have your left and
Mm-hmm.
your
Mm-hmm.
right element. What I always do and recommend anybody does is put a one-to-one on there. And so the reason you call it a one-to-one is because it's a one-to-one impedance ratio. Hopefully you have 50 ohms on either side of your on. And that helps you out. And people are like, well, you don't need it. The problem that we have is that coaxial transmission line, like everybody's like, balance stands for balance to unbalance, and that's all you need to know. Your coaxial transmission line has three conductors on it. Most sometimes that's a little bit of shocking news to folks, but you have your center conductor, right? The center pin of your coaxial cable. And then you have the shield, which is outside your dielectric, which envelops the center conductor. So that shield should be like a mesh, like a wire braid that's on there. And you can actually transmit current down the inside of that shield and on the outside of that shield. And regardless of whatever dipole somebody makes, they're going to have current on the outside of their shield. Now, a lot of people say they don't, but I don't see those folks measuring it to show you that they don't. And that current's typically referred to as common mode current. Technically, it's not common mode current, but that's what folks call it. And I'm sure that gets folks upset when I say that technically it's not. But the problem is that when you are shooting energy out of your coaxial cable into your antenna system, there's energy coming back in because we use AC current, differential mode current. It's going one way and the other way at the same time. Electricity and current in general always looks for the path of least resistance. And so you may have less resistance on the outside shield than you do on the inside part of the shield, or equal resistance. And if you do that, the current splits both ways. And so that current that travels on the outside of your, if you went outside with a field strength meter, you would see that your coaxial is radiating energy like an antenna. It's like a third leg of your dipole antenna.
Mm-hmm.
If you don't choke it off. So one, that's energy that's going where you don't want it to go, right? Which reduces your overall antenna system efficiency, but also that radiation coming off of your coaxial cable affects your near field. So like within about a quarter wave to a half wave of the lowest frequency that you're operating on, it's called the near field of your antenna. And that's when you have all this radiation pouring off of your antenna system. And in the near field, it has to kind of sort itself out. It bounces off of it, or reflects off of the other radiation. And then you get what's called your far field. And we look in antenna modeling systems at far field plots. When you buy an antenna, they'll say, oh, look, this gives me an extra 2 dB gain in this direction. They derive that from the far field plot that radiates off of that antenna. If you have your coaxial cable radiating, you can throw all that out the window, right? Because that's going to impact it differently than you want.
Mm-hmm.
And so folks will say, well, why does this happen? So when you're pushing current out, you have current coming in. We talked about the path of least resistance, sometimes on the outside of the shield. The other thing is that no matter how good you are or how good you think you are, and you're cutting the legs of that dipole, they're not the same length. And everybody's like, I'll hold it straight. I got a steady hand. I measured twice and cut once. But they're different lengths, right? And even if it's just a little itty teeny bit, when you're talking about current that's moving at the speed of light, that matters. And then your timing gets off. So if you use the one-to-one balun at the feed point, that helps regulate that, and then slows it down so that your current is all the same when it's coming in and out of your transmission line. Also, the current on the outside of the shield can come into your shack, and it can create interference. It can mess with your SWR, which messes with your power delivery. And it can actually, it's looking for a path to ground. So it's going to go into your radio. If you got your coax or your USB cable hooked up and you're not choking that, it can go into your computer if you're doing FT8 and can cause problems there. It can even shock you.
Mm-hmm.
So the thing is that you definitely want to use them, right? I mean, it's just a good idea.
Interesting. I'm learning a lot.
I had something here I was going to show you, but now I can't find it. Give me a second.
Yeah. I enabled screen sharing.
I got it. And this is actually a choke. So a lot of people will call this a balun, but it's actually a choke. And this helps attenuate signals on the outside of your coax. So a balun and a choke do mostly the same thing, right? Which is create impedance on the outside of your outside shield of your coaxial cable.
Mm-hmm.
So some folks will use something like this as a choke. What I would tell everybody is that you should have a choke, whether it's something that you like this or something that you made like this, which is just a toroid with coax wrapped around it.
Is there a difference between the two, or they just do the same thing?
Actually, this one, the one on the toroid performs better, but they do the same thing.
Okay.
And what I do is I have one of these on the back of my antenna tuner, so it gets any coax that would be coming down get any CMC that's coming down my coax, and then I have one at my antenna feed point. And then what they suggest is that you put one every quarter wave of the lowest frequency you're going to operate on your transmission line. So if you have like 100 feet of coax and you're operating on 40 meters, quarter wave, that would be 10 meters, right? So about every 30. So you'd have two of them on your 100-foot transmission line, which would help you out with any of that noise or interference.
Interesting.
Your buddy Paul saying that choke on the end of his end fed drops his SWR down as well. Yeah, absolutely, because your current is not flowing correctly without a balun or a choke on the coaxial cable.
And I know ABR sells antenna cables that have that choke already done or part of it.
Yeah, well, some people tell you that, hey, when you have it like this as a separate component, you're adding 2 extra termination points with these connectors. And there is a loss in these connectors. Now, the loss is almost minuscule, But some people get uptight about that, and so they want that as part of their coaxial cable.
Mm-hmm.
It's fine for home installation. Where it gets problematic is if you're going portable and you have to wind that cable up, then it becomes a real pain.
Interesting. And so what so that's chokes and somewhat the balance. So what is the toroid doing when we're doing like an end fed configuration? Because they're
Well,
used.
it's a little bit of a different thing. You're using it there to do an impedance transformation, and you want to match your antenna system to your coaxial cable. So there's a couple of different kinds of transmission line transformer. Some people get upset if you call it a transmission line. What's up, Uber Geek?
Yep.
If you call it a transmission line transformer, some people call them match boxes, some people call them ununs, some people call them trans matches. But really, what it's doing is it's matching the impedance. So when you think about your dipole and you feed it in the center, everybody's like, well, that gives you a 50 ohm match. If your dipole is actually a half wave off the ground, which is the recommendation, right? If you look in the ARRL handbook, it says,
If you can get it halfway up the ground.
yeah, well, if you have a 10-meter dipole, for example,
Yeah.
right, you only got to get it 16 feet off the ground. And if you do that, the feed point impedance there is 72 ohms, give or take. It's not quite 50.
Mm-hmm.
The reason I'm telling you this is that if you move that feed point to the left or to the right, like so, if you're going to have a off-center fed dipole, for example, or even if you cut your legs wrong, just a little bit, it'll change the feed point impedance. So if you think about the dipole, and if you took a look in modeling software, you would see that the current is very high at the center of a dipole and the impedance is very low. If you look at the ends of it, the current is very low and the impedance is very high. So when you move your feed point off center, either to like 2/3, 3/4 of the length of your dipole, or all the way to the end, like you do in an end-fed half wave, an end-fed half wave is actually an end-fed half wave dipole. It's just a dipole fed on the end.
Mm-hmm.
So the impedance there is significantly higher. It's around 2,450, I think. It may be higher, maybe 3,000. It's going to depend on the wire and how good of a job you did cutting it and all that kind of stuff. And you need more of an impedance transformation. So we use a 49-to-1 or 64-to-1 unknown to do that impedance transformation. So what it does is that it presents itself as 50 ohms on the input. So this is one of the first generation
Ooh.
Cartenas. So what it looks like, in the input of this is 50 ohms here, and then when the output right here, it's going to see 2,450, give or take. And then the job of this unknown is to transform that 2,450 ohms down to 50 ohms. So you get effective power throughput. So like
Mm-hmm.
that's why hams get worked up over SWR. So it's really about, hey TC, it's really about matching your transmission line to your antenna. And we do that so we don't get any reflection. And when we don't get any reflection, whatever power we're pushing minus losses created by the coaxial cable, all coaxial cables got some loss in it, then that is going to make its way to your antenna. And then hopefully your antenna is good enough that it radiates all of that. We know that the antenna absorbs some of that energy
Mm-hmm.
and then radiates it as heat via ohmic resistance. But what we wanted to do is we wanted to radiate via RF. So that way we get our money's worth out of our 100-watt radio. Does that make sense?
Yeah, because it's a trick to, like you said, to make the impedance kind of match what you're doing and send all your energy, RF energy, into your antenna wire to radiate over RF and not to radiate over heat, and also help prevent the feedback coming back from the antenna when it's not matched 100% and getting into your radio with the chokes. Those are the chokes. I kind of went down the choke path also.
Yeah. Well, what the choke does is it stops current from the outside
Yeah.
shield of your coaxial cable coming back in your shack and creating havoc.
Hmm.
And then the ununs is really what they're called, or what they're doing is they're matching your impedance. So we have, again, our antennas, we have a 9-to-1. This one's not complete. This is a
Hmm.
9-to-1 unun. And I just did some videos on a bunch of these.
Ooh,
And these do a 9-to-1 impedance.
very Christmassy.
Yeah, transformation, which is 450 ohms. So like when you feed they call it a random wire end fed antenna. but they're anything but random because
Hmm.
there's specific lengths that you're supposed to use. And what you want is that you don't want them to be resonant on any amateur band or harmonic thereof. So there's I don't know 40 different lengths of random wire that you can choose from.
Okay.
And you should have about a 400. If you use one of those, you should have about a 450 ohm feed point. Um, I'm not. Oh, you're talking about the Mercury amps, not the Mercury antennas. I was wondering what you guys were talking about in the chat. Um, you should have around 450 ohms of
Hmm.
impedance, which the 9-to-1 should bring that down and present 50 ohms to your coaxial,
Hmm.
which is also present at the feed point of your radio.
Since you mentioned the chat real fast, TC Fitz, I saw you in there earlier. Thank you very much for the $10 super chat. Happy Sunday to you. I appreciate it so much. Probably next stream we'll be drinking the nasty whiskey. Not one I have as such a respectable guest.
What is the nasty? What's the nasty whiskey?
Oh, you brought it. The nasty whiskey. This is the mango habanero whiskey, which I got
Yeah.
for Christmas. Um, it was bought with love, but it tastes so bad. Super
Well,
sweet. Like
yeah,
it's so sweet. Like my face like tenses up, and and then it has a habanero kick to it at the back end, which I really love habanero, but it's so sweet, and then the habanero spiciness is so delayed. It's like a second punch, and it's
yeah.
mm,
I don't like flavored whiskeys that much,
mm,
so I don't typically drink them. Like habanero. What is the other thing on there? It's not peach,
mango,
right? What mango?
mango habanero.
Like a mango habanero hot sauce. Now that sounds pretty good,
Yeah,
but I don't know about a mango habanero whiskey.
no, it was bought with love, and I was intrigued until I opened it, and I was like, oh,
Well, I got to
oh,
tell you, man,
I'm gonna drink this on stream.
somebody gave me a bottle of Booker No maple bourbon.
Hmm.
And I was like, man, I'm never going to drink this. Well, I drank it. And I got to tell you, man, when I opened up, it was like drinking pancakes.
Ooh, yeah.
I was like, yo, I'm getting drunk on pancakes. It was fantastic. I
The
loved it.
Knob Creek's maple is
Maybe it
like
was
that.
Knob Creek. Maybe it was
Yeah.
Knob Creek. I
I
was thinking it
bought
was
that
Booker
for
No.
a friend, and I'm like, me and him were just trying whiskeys left and right, experimenting, and I bought it for him on his birthday. We opened it up, and he's like, "Man, I appreciate the gift, but this is god awful." I tried some. I said, "My bad. I am going to buy you another bottle of whiskey later for that."
Yeah, they're all talking about Miller Lite flavored whiskey. So I used to drink
Oh.
whiskey often, and I had a really nice. Whenever I'd get a bonus from work or anything like that, I'd go out and buy nice bourbons and stuff like that.
Hmm.
Originally, when I started drinking a lot of more, I guess the hard stuff, I was buying tequila, and the problem with tequila is so damn expensive. So I switched to bourbon. This is before the bourbon boom,
Hmm. Hmm.
and I used to have stacks and stacks of bottles of Rip Van Winkle,
Ooh,
and
what?
and I had like bottles of the 23, the 20, the lot B15 was my favorite. Stacks of this stuff. And I even started emailing Robbie Van Winkle, who's one of the Van Winkles he was in charge of the mash bill at the time, and I would talk to him all the time. And I started to drink less and less whiskey, but then Anthony Bourdain started talking about how Van Winkle was the best whiskey that you could buy, and the
Hmm.
prices just skyrocketed.
Hmm. Hmm.
So I was getting like the Lot B, the 15-year-old Van Winkle
Ooh,
for $49 a fifth, and then I was
what?
getting the 23 for about $200. So I sold a bottle of the 23 for 2 grand, and I made I did really well.
Yeah,
Um, I sold, I don't know, maybe 15, 16 bottles of
yeah.
bourbon,
Do you have any
and
still around?
cleaned up thanks to him. But now you can't get it. It's unobtainium.
Yeah,
And I got to tell you, the Lot B, the 15-year it's the best whiskey I've ever drank. But I don't, it's not worth the money that folks are asking for it.
yeah. Oh, I agree. Um,
I wouldn't
I
even think about trying peanut butter whiskey,
we
T-Ray.
we could
I
talk
leave the
about
candy
whiskey.
flavored stuff, like the peanut butter beer and I leave that to the kids.
Hmm.
Um,
We could circle back about around the whiskey a little bit here later. Um, we got Aaron from the chat here. Great topic. He's going to have to build a 49-to-1 Balun. Um, but it needs to be able to take 2,000 watts on sideband.
Well, that's more than the legal limit. I won't say anything to anybody about that, but 1500. So
Mm-hmm.
when you start building the ununs, there's a lot of things that you need to take in consideration. One of them is the power requirement that
Mm-hmm.
somebody's going to put on that thing.
Mm-hmm.
The other one is that the bands that you're going to operate on. So these toroids have a attribute called permeability, and that is their ability to either retain or dissipate electromagnetic energy, right? So that's the magnetic field. So when if you just have a straight wire and you run electricity through it, it produces a magnetic field around that wire. It's so minuscule that you don't notice it and it doesn't cause anything. If you start wrapping it into a coil and bigger and bigger and bigger coils, more and more windings, the stronger that electromagnetic field around the coil becomes. Now, if you just make a straight up coil that's called an air wound coil, and there's nothing in the center of that, and so you would say that that has a permeability of 0. And then there's some toroids that have a permeability of, say, of 200 and some that have of 2000. So depending upon the magnetic properties of the toroid that you're using, so they're all different, they perform better at different things at different frequencies. So if you're going to look to do two gallons on 160 meters, you might want a different stack of toroids than you would use at 10 meters, for example. The other thing that you can do is that you can buy bigger toroids. Like, so for example, here's a big old
Jeez.
toroid, right? They handle more and more power, but typically what folks would do is use a stack of these. This is a K type toroid. They're very popular on the lower bands. Or you would use like a mix 52, for example, and then you would take 2 or 3 of these. I would go with 3 if I was doing that,
Mm-hmm.
and you can crazy glue them together. Some people say roll a thing of electrical tape around the end, but electrical tape is insulation. Insulation traps heat. Toroids under use get hot, and when they become too hot, they hit something called a Curie temperature, and at that point they become non-ferrous, meaning non-magnetic, and they cease to work. Now, if you let them cool
Interesting.
down, they're just fine, and if you get them too hot, they might explode.
Oh, really?
Yeah,
Oh, that's interesting. So what's kind of the main differences? I hear people talking a 56 to 1, a 49 to 1, and a 9 to 1. I know it's differences in the wraps,
it
but
is
what's that
differences in the wraps.
equates to?
So what it does is that it just changes the impedance on the other side, right? So like if you were going to use somewhere around, I think 3,200, and that's a guess because I'm a calculator.
Yeah.
If that was the impedance of your wire and antenna, then you'd probably want to use a 64 to 1. So what a lot of people do is they'll have a wire that they have hanging up in the air, and then they put a unknown on it and say it's a 49 to 1. And if it's not matching right, they'll add an extra turn to it, or they'll remove a turn. And some people will use, so here's a 49 to 1. We'll talk a little bit about how we get to 40. I don't know if you can zoom
Yeah.
in on that, but
That's all on you.
all right. Well, so you have a primary, which is 2 twisted pieces here. Now you don't have to twist them, but I'm not going to get into that. I twist them. 2 twisted pieces here, and that is your primary 2 turns. Now, one of those that's entangled in that twist is also my secondary wire, which wraps around 14 times.
Mm-hmm.
And so what you do is you take 14, you divide it by 2, it gives you 7. You square 7, it gives you 49. That's your impedance ratio. Now you can do a 3-turn primary with 21 turns. 21 divided by 3 is 7. 7 times 7 is 49. Now, on your 21 to 3 ratio that you have on your windings, if your antenna is too low, if the impedance is too high or too low, you could do 22 windings divided by 3, and that gives you a little bit of a different number of impedance on there.
Okay,
So
so
that's why
so
people start.
walk that back again.
All right.
All right. So the number of primary turns is the 2 wires together. You do 1 or 2 of
Right.
those, so sometimes 3 of them, and then
Right.
you take that, and then one goes to one twist is one way, and the other twists the other way. So
Yeah.
that's what
So
they
what,
do.
what,
2 numbers
what you
there.
do is when you could even do math live. So what you do is that when you make a toroid like a 49 to 1, you take a long wire, right?
Mm-hmm.
And then you fold the end of it over.
Yes.
And then what I do is I twist that up.
Yep. Yep. Yep.
that twisted piece is both wires, right? So if you think
Yes.
about it, and you put that, I fold it through twice, two
Yep.
turns, and then I take the real long end, it's called a tag end, and I'll wind that around 12 more times. But that wire is part of the original two, which gives me 14 windings,
Mm-hmm.
right? And so what I do is I have two primary, 14 total. So if I
Yes.
take my 14 total and I divide it by my primary, that gives me seven. Seven
Mm-hmm.
times seven is 49. So that's how I know it's a 49 to one.
Now you just lost me. I really want to try to understand this. So I understand the two, and then
Let's
you
do
do.
this.
Yeah. Yeah.
Let me go to my other camera
Yeah.
because I forgot that I had it. All right. And maybe it's easier to see on this one. So that's probably a little bit easier to see.
Yes. Yes. Perfect.
So this is my primary where
I.
these two wires are twisted.
Uh-huh.
So I got 1, 2, 3, 4, 5, 6, 7, 8 is the crossover. Then I got 9, 10, 11, 12, 13, 14 windings of my secondary, right?
Mm-hmm.
Because my secondary is part of these two. So if I take my secondary 14 and I divide it by my primary, which is 2,
Two. Mm-hmm.
then I get 7, right?
All right.
14
So
divided by 2 is 7.
I'm following you to this point.
All right. Now if I take the square root of 7,
Mm-hmm.
look at my desk, it's a mess, ain't it? If I take the square root, if I take 7 and I square it, that gives me 7 times 7 is 49. And that gives me my impedance ratio, 49 to 1.
Because that's what the toroid's doing. After we do the initial math, then
Right.
it's kind of like acting like a transformer a bit, and then that's why we're
That's
squaring
exactly
it.
what it's doing. Mm-hmm.
Okay,
It's
because those are the
transforming.
primary turns. Because that's all that's feeding into our two secondary turns.
So what it if let me go back and take it. Let me go back to my picture here because the way that these work, like everybody builds them,
Mm-hmm.
and then they reach out to me and they're like, "How come it works like this?" So your primary comes out of your center conductor. You can see it right here on this BNC thing, right?
That's the two strands
That's
soldered
one of them.
together.
That's one
Oh,
of them.
that's one of them.
And then it gets wrapped around twice, and then right here at my ground or my shield, I connect both of them to my shield. So everybody's like, "How does that work, boy? That ain't right because you're shorting your center conductor to your ground, and you're absolutely doing that.
And that's
So
a
you short
capacitor in the middle or a resistor.
that is a capacitor, but we're not worried about that right now.
Okay.
So what we do is that we have a short going from our center conductor to our ground, and that's wrapped around the secondary wire, which goes from the ground straight out.
Mm-hmm.
And so people are like, well, how does that work if it goes from the ground straight out? When you wind these two wires together or even have them next to each other, remember we talked about when you feed electricity through a wire, it creates a magnetic field.
Yes.
So what this is doing is it's creating electromagnetic induction. And so the one wire creates an electronic field, which then imparts itself on the second wire, which is the one that's wrapped around here and then goes out.
Mm-hmm.
So it's a little tricky, but that's how it works. Now, what we do with this capacitors, we use this to provide another path from here to here with less inductance. And so, like, if you don't have this capacitor on here, your SWR in higher bands gets a little messed up. So if you remember back to the general class when we studied tank circuits, the values of the inductors and the capacitors in those circuits, when you change those, they become resonant on different frequencies. And what's happening here is that when you put this in, this becomes more resonant in the higher bands. So like I've got videos where I show an SWR suite with and without the capacitor.
Mm-hmm. Mm-hmm.
And the SWR comes down on like just after 20. So it's like 17, 15, 12, and 10 is where it comes down.
Interesting. I'm absorbing and processing here. Um,
Yeah,
I think
Random
I'm
Wire
getting.
saying that there's an antenna maker that has a switch on their end fed that will do 49, 56, or 61.
Yes, I seen
You
that.
can
It
do all that mess.
was that X
To me,
antenna?
that's just gimmicky, right? Just build the damn antenna and build it right. And if your impedance is high or it needs to be lowered, so just make the unknown differently. Um, because that's just extra junk that's going to be in your circuit that you don't necessarily need.
Mm-hmm.
Hey,
Yeah.
Chuck.
Is Chuck in the? Yes, he is. Hey, Chuck, man. Nice seeing you. You're amazing. I bought the antenna from you.
So you got one live. He handed it over to you.
Mm-hmm. He said, I asked him like what's going on with Coffee and Hand Radio when we're at Dayton, and he's like, oh man, I got a backpack full of antennas. I was like, I've been meaning to buy one. He's like, all right. I forgot how much it was, and I handed him cash. Here you go.
So I've had an NFED up out back for, I don't know, 2 or 3 years. It's been out there for a while. And while we were at Dayton, my wife calls it. She's like, your antenna came down.
Uh-oh.
And I was like, what? And so I went and looked at it. What happened was is that I used a zip tie at the end of the antenna to connect it to the insulator.
Uh-huh.
And I guess the UV finally burned up that zip tie.
Mm.
And so when I got home, I was like, I need to put up another antenna. And I wanted to put up a 9-to-1, but I didn't because I don't have a tuner for my Sun SDR, which is the radio that I'm using mostly right now. It was never a problem with the NFED because it's near resonant on multiple bands, and I just had a good old time with it.
Yep.
So I had no idea that I could use my LDG AT100 Pro 2 tuner that I used in my 7300 without a control cable. Like I just thought, like when I bought it, and it was years ago, I was talking to the guy, and he's like, "Oh, you needed a control cable for your 7300." So in my mind, I always needed a control cable for that, and you don't. And so Jim FEP Labs was telling me that he's using his on his Flex with no control cable. And I'm like, BS. I didn't believe him. I made him go videotape it and all this other stuff. And I was with Chuck at the time. And we were both like, well, damn, it looks like it's working. So I put my 9-to-1 up and I just messed around with it real quick. And I got it to tune without the control cable on my Sun SDR. And I'm like, sweet, I'm in the game. And so the other day I was playing around with it and I couldn't really get it to tune many bands. Chuck's like, well, did you sweep it? What? And I never sweep 9-to-1s because they're non-resonant wires. You use a tuner anyway. So I just don't spend the time sweeping it because I'm going to tune it anyway.
Mm-hmm.
And I'm like, man, it's like 80-to-1 on 20 meters. And I cannot figure out what the problem is. Now, my back fence is going to be worked on next weekend. So I mounted the and I don't know if I'd loose, like mount is a loose word, to my side fence, which has like a wire mesh on it.
Mm-hmm.
And so in my mind, I'm thinking this wire mesh is creating reactance that's sticking with my SWR and it's causing me all these problems. And Chuck it's right down RF sensing. And Chuck's like, you need to sweep it and see what's going on. And so what I did, instead of sweeping it, I went out and I disconnected the antenna from the coax and I put a dummy load on it and I swept it. And now the SWR was 190-to-1 on 20 meters, so double.
Ooh.
And I'm like, what the F? So my coax is bad. I ran 100 feet of coax today, went out, and now I'm wanting a 3 on 20.
Nice.
But
Nice.
I just tell the story because it's like I had this was actually out there connected to the bottom of my unun. And I was like, I don't know if this went bad or whatever. So I switched this out for another choke, and I was doing all this testing because there's all those components out there, but I got it working. And actually 9-to-1's like one of my favorite antennas. So I'm really glad I got it out there running.
So, but 9-to-1s, most 9-to-1s I've seen have a counterpoise. Unlike a 49-to-1, most of them I seen don't have a counterpoise. Is that because, like you said earlier, they're not completely a resonant antenna?
Well, the thing is that, so this is going to be opinionated and it's going to get everybody upset.
Perfect.
You always use
More
a
comments.
counterpoise. You always use a counterpoise. Now, a lot of antenna manufacturers will say, this 9-to-1 is so effing great that you don't need to use a counterpoise. So you don't need to use one with any antenna. And what happens is that, remember we were talking about the alternating current, right?
Yep.
AC current, differential mode, and it's going out and it's got to come back in.
Mm-hmm.
So what is happening is that current's coming down your coaxial shield. And it's using your coax as your counterpoise. I prefer to have a counterpoise that I can direct because we talked earlier about how when you have your shield working as a counterpoise and you have common mode current going down the outside, it becomes part of your antenna system. And I don't want that. You can choke it at the feed point. You can choke it at your tuner, but then you have to use chokes. And many of these antenna manufacturers are not telling you to choke the antenna if you're not using a counterpoise. The best thing that you can do is ground it. ground your antenna. The second best thing is use a counterpoise.
Mm-hmm.
Third best is counterpoise and a choke. And then the fourth best would be just use your shield and pray.
That's what
And the
I do.
thing is that look, as we get into amateur radio, it's a progression where we learn. We learn stuff every day. We operate. We learn every day that we play ham or do anything like that. When we look to when we say things like, "Well, you don't need it for a 9-to-1," or "You don't need it for a 49-to-1," that's all bullshit. The 9-to-1 and the 49-to-1 work exactly the same. The only difference is the amount of impedance that they transform. Now you might have one that's a current balun and one that's or unknown and one that transforms voltage, one transforms current instead, but they all do the exact same thing. And AC current doesn't magically change based off of the number of turns that you have on a toroid.
Mm-hmm.
So I tell everybody ABC, always be counterpoison. It's within your best interest.
Mm-hmm. Awesome, awesome. Well, I promised it earlier, and if you don't mind, I am going to open up a box here that I
It's your
got
show, man.
from.
Now, on the Zoom, I'm not used to all these third-party applications when the live show. Okay, I was gonna say because I didn't see you on there.
Yeah. Here it is. Um,
Who sent that to you?
This is from Michael. He tried to reach up with me when I was in Dayton, but on the first day, man, that first day, I was stuck in building 1 for 3 hours. 3 hours, and that was just meeting and greeting everyone who coming up to me, and I loved every minute of it. Don't get me wrong, but I need to run out and get more of the show on camera. So
Jason saying that ABC is always he thought it was always be choking. Well, I say ABC always be choking if we're talking about choking. I always say ABC always be counterpoison if we're talking about counterpoison.
Mm-hmm.
And there's a few other things that I use that C for. But we won't get into all that. But yes, you should always be choking and you should always be counterpoison. There's no question about it.
So Michael came and we did meet up because I was off trying to film, and I didn't. What I'm filming I usually have my phone on turn off all data, so I save the battery. Because if you turn off your
stick,
if you turn your Wi-Fi off, you turn your data off, man, your phone will last 3 days. But time I turned it on and got all my messages, we missed each other. So I apologize. So he sent me everything here. Ooh, look at these.
It looks like licorice, right?
Yeah. Oh, those are awesome.
That's the good stuff.
Yeah. That's amazing. And a scratch-off ticket. The
Nice.
ticket, I need to dig it up. This was from one of his friends who watches my channel, so they tossed everything in there for me. Ooh, look at that! Oh, the color's not coming across right, but this is a bright orange. There.
So it's tactical orange?
Yes! Oh, man. This is so cool! Yeah, I have an antenna, long antenna. I'm going to wind around this. It's going to show up in my Potopack. And what else we got in here? There's another box. I'll open up in a second.
Well, while you're opening it up in a second, Paul's talking. He's talking mess about adding his counterpoise immediately and all that. What I would encourage you to do, Paul, is use the VNA to take a look at where your readings are on a Smith chart, and then you can see if it's resonant or not. SWR is not the be end all for antenna efficiency, right? So you can have a lower SWR, but have capacitive or inductive reactance and not be resonant. You can be resonant at a 5-to-1, 7-to-1, 9-to-1 SWR, and then your antenna may perform better. So what I would encourage you to do is take a look at see where you are on the Smith chart, and then potentially adjust the length of your counterpoise end or element. Take a look at it that way. All right, where are we at?
Oh, he sent me the good stuff, man. He sent me some great cigars. Oh,
well, they're washed out. They look like Davidoffs, but what are they?
Yeah, Davidoffs. There, take off the lights. There we go.
There you go.
There, Davidoffs. Oh, it's a good sample pack. 5 different cigars. Ooh, Michael, you are amazing to me. Wow. Thank you. Oh, I appreciate this so much.
Yeah, that's a nice little score you got there.
Yeah. And they come, oh, ha, in their little own box.
Sweet.
I'm going to take this up to the cigar bar, and they're going to be like, what did you do, Frank?
I'm gonna be like, Frank's up here big timing us.
Yeah, I know, right? Oh, that's so beautiful.
And I love sampler packs like that. It's the way to
Dude,
go.
that's awesome. Thank you so much. It was just too hot to be outside for a couple hours today. It's decent now. Plus, Texas is threatening to storm right tonight, so we got that to look forward to. That
You got a
is,
storm coming?
yeah, it's threatening. I don't know when it's going to be here.
So do you have an HF antenna up at the
N-
house now, or
Nope, no antenna right now. Yeah, that's on the box. That is so awesome, Michael. You are the man. I'm gonna have to scratch this off later, and I'll post, take pictures of if I want any money.
now what did you do to Michael so that he was so generous towards you?
he Michael is amazing to me. He is very, very generous. He's helping me support the channel a lot. Um, I don't, I man, he loves my content. He loves my personality.
No,
Ed,
it's fantastic.
Ed, there is a channel supporter member. Thank you very much. I appreciate it. I forgot how many months that little blue thing is, but I appreciate it. Um, No, he's helped me a lot in the getting the Radio Shack set up. To get back to your question, no HF antenna right now. I'm in the process of building out my shack. I have put the antenna tilt over mount up on the chimney. That
Nice.
video I'm cutting right now, and I like to get it out here soon. And then next would be the outside conduit box for the antenna pass
Mm,
through the roof into the outside, and it has a aluminum ground plate that is going to be all the UHF VHF ground rods connected to that grounding plate through lightning arresters and coming into the house there. Phase two, which is going to be later after the summer when it starts to cool off, is when I put the HF antenna, a second junction box lower. The first one's going to be high on the chimney because the UHF VHF antenna is going to be on the roof. And I'm on the second story of my house, so I didn't want to run the antenna cable all the way down to the ground to get that pass lethal distance to the ground, then back up to the second story and into the house because UHF VHF losses are pretty bad. So I'm going to have that junction box, a first one high, and at the point where it's going to come into the house, and lightning arresters, and then have the path to ground straight down. So it's going to be a longer run of cable to get to my radios and into the house. So
so you're
hopefully,
gonna put the lightning arrestor up on the chimney, right?
yeah, it's going to be close to the chimney. It's going to be a little below, and it's going to be in that junction box before the antenna cable comes into the house.
And then what are you running down for your ground lightning
Uh,
wire?
I am a thick copper cable of some sort. I forgot the gauge I chose, but
You're using stranded. You're using stranded or solid. I'm just asking because I
blue
love
blue
learning.
blue blue. When I decide, yes, one of them. If you have
Gotcha.
opinion,
A
tell
lot
me.
of folks, a lot of folks recommend you actually use a wire braid for that.
Mm-hmm.
So like current typically travels on the outside of the wire, not the inside,
Mm-hmm.
right?
Mm-hmm.
So that's why they say that that works a little better.
Mm-hmm. The other big part is I got to, since the where the antenna is coming all the way down to the grounding rods for the antenna. It's on the opposite house ends of my house for the ground rod for the house electrical. So I'm gonna
Mhm.
have to bond those two together and drill grounding rods about every 11 feet or so
Yeah,
until I get there, so everything's bonded correctly. Um, yeah, that's a whole big
that's a
project
lot of
coming up.
work. That's a lot of work.
Yeah, yeah. It's slow coming, but progress is being made. I'm hoping to get the junction box up later this month. Videos on everything and start wiring things up. I'm really getting close. I'm about to cut holes in my walls. That's how close, and holes into my siding. Yes, buy a lot of caulk because I want to seal them all up too because water is the enemy. What is
Yeah,
up,
you don't want water coming in.
Soda and Ham Radio? Well, we're almost at the top of the hour here, so I'm gonna go ahead and throw it to you, man. Ape, where can we find you? And what's your call sign again?
You could, if you want to listen to me drone on for hours and hours on end about stuff that's confusing to me, you, the smoking ape at on YouTube is the best thing to do.
Mm-hmm, mm-hmm. Awesome. When we were talking about coming on, I did say, "Hey, man, can I get your call sign for the tags?" You're like, "Oh, it was
So
this
close,
close,
so
this
close.
close. Almost tricked you. Darn." Man, you're a wealth of knowledge for amateur radio. Thank you for coming on.
I know.
I
Thanks for having me. Had a great time. I hope I
really
wasn't too
appreciate it.
preachy.
No,
Um,
no, you are amazing. Anytime you have a topic, I'll love to have you back, and I will be hitting you up to explain more things as I dive down more deeper into this awesome hobby of ham radio.
yeah, man. Anytime. And then just remember, boys and girls, always be counter poison.
And I always be counting poison. ABC. Let me throw here real fast. I'm Frank. Take radio. Wearing this awesome Icom shirt from Dayton. Thank you to Icom for handing that out to us. Just gonna run down the list again here real fast. Thank you to all my supporters. I really do appreciate each and every one of y'all. Whiskey tumblers links are active now. Last week in the tumblers, so order yours now. I don't know when I'm gonna sell them again, so if you want one, go ahead and buy it. And coins are still for sale. And thank you to everyone listening to this audio or watching me on YouTube. Either way, you support the channel, and I appreciate every one of you. And to all my tankers out there, go forth and conquer. Say bye. Adios.
Bye. Thanks again. Had a great time.
A quick shout out to all my Patreons who make the show possible. You can support me by joining Patreon in the link below. And on to Tank Radio.